Okay, all right. So we're gonna start just now. Actually, now for the grade eights. Thank you so much for waiting. Yeah, I just had a bit of a hold up here at home because you know how things are. Obviously, all of us should be on holiday, but you know what? We are here doing maths very early, and I just want to say hello to the grade eights. Hello to the grade eights. It was very nice that some of you could join in. I know that our grade eights are coming from grade 7, and the fact that you have made the effort to be here in this live session is, to me, a indication that you guys are very serious about doing very well in math. So hopefully this journey that we'll be on, which I know is during a time when most of you feel like I should be on holiday, I should be enjoying, but we will spend 30 minutes. Okay, I promise to not keep you for more than 30 minutes. So for the grade 8 learners that are coming in for these live sessions, I am basically the person who is behind this particular channel, Maths is a Game. This is basically a maths channel that I started early this year. All right, and when I started it, it was simply me sharing video lessons on different sections of grade 11 maths and grade 8 maths, because this year I was actually teaching grade 11 maths and grade 8 maths at the school that I'm actually teaching at. So I started sharing lessons, lesson videos, not really live sessions. But then towards the exam period, I started doing live maths sessions for grade 8s and 9s. And specifically, I was going through question papers and was helping people to sort of prepare for their exam season. And there's a lot of papers that I've posted onto the channel. So if you go to my homepage, you should see that there's a lot of grade 8 and grade 9 papers that I've posted from different provinces, and also some of the end of year exams that are written at the end of the year. So those are there for you to look at, and you can look at them as much as you want. But I decided that during my holiday, I'm going to dedicate a part of my time to helping grade 8s, 9s, 10s, 11s, and 12 with their maths. So you are coming from grade 7, you have hopefully received your report, and you know that you're going to high school. So next year you'll be starting a very new journey of high school and high school mathematics. So if you find that these live sessions, they are beneficial to you, they are helpful to you, and they assist you in any way, then I would advise you to continue to join all of the other sessions that are coming up. So what I'm doing here is I'm actually exposing all grades, grade 8, 9, 10, 11, and 12, to the syllabus that they will be covering come next year, term 1. All right, I'm exposing you to this syllabus early in grade 7, which is basically you are done with grade 7, but I'm exposing you early now so that by the time you start doing that specific work next term, it's kind of like a revision for you. But also it helps you to actually be able to become confident in your mathematics, because if I'm explaining something here on the platform and you have questions, I'm hoping you will write there on the comment section. You will ask me something that you're not clear about, all right? And if there's something that you are lost about, you will actually make the effort and ask me about it. I am doing this freely, you are not paying a cent. Obviously, you're going to have data and all of that stuff so that you can, log in. But I'm doing this freely, and the reason why I'm doing it is because I really want to assist maths learners in the country to be able to do well in mathematics. Also, I want to create a culture hopefully with those people that join in and become part of the Maths is a Game family. I want to create a culture of actually, ease in doing mathematics. Maths can be very easy. Just like the channel name says, Maths is a game. It's a game, guys. The more you play this game, the more time you spend playing the game and the more familiar you are with it, then basically it becomes easy. When are we doing grade 8? We are doing it now, all right? But I'm just doing some introductory remarks here, just welcoming you all as grade 8s, all right? So the session for grade 8 is starting now, all right? And if you are a grade 8 learner and you are wondering, what am I doing today? I'm actually going to be doing the very first topic that you guys do in grade 8 at the beginning of a school term in grade 8. And the topic that you guys start with is not a topic that you are not familiar with. It's a topic that you've done in grade 7. So I'm going to also sort of like, in certain places, sort of like tell you about some of the things that you've already done. And I'm sure as I go through them, you'll be like, "Hi man, we've done this before. We did this when I was in grade 7. Much of the mathematics in grade 8 should be familiar to you. It should be maths that you've already done in previous grades. So hopefully that puts you at ease, because I'm sure most of you are like, I wonder in grade 8 what's happening. But in actual fact, you'll find that much of the things that we are doing here are things that are very familiar and things that you have done in grade 7. Okay, so without any further ado, let us start. Okay, let us start this session. So, like I said, we are going to be looking at a topic called whole numbers. Now, I know for a fact that most of you know what whole numbers are. The spelling of whole is not H-O-L-E, but it's W-H-O-L-E. And that kind of whole means complete, To be whole means to be complete. All right, so these are complete numbers, as we would call them. If we were to call them loosely, we would say they are complete numbers. All right, now, funny thing is, you guys use whole numbers every single day in your day-to-day life. All right, if you look at the time on the clock, all right, that's basically, a utilization of whole numbers. If you check the date on the calendar, that's utilization of whole numbers. If you were to ask yourself, how old am I? All right, your age is an indication of whole numbers. So whole numbers are basically numbers that you use every single day. All right, we refer to whole numbers when we call them loosely. We say that whole numbers are simply counting numbers. And counting numbers, all right, are basically the following. All right, whole numbers, by definition, what are whole numbers? Does anyone know? Because like I said, this is not a new topic. Some of you coming from grade 7 should already know what I mean by whole numbers. Does anyone know in the comment section? Can anyone comment for me? What are whole numbers? What is a whole number? Anyone? Whole numbers. Whole number is a number that is complete, yes. But let's be more specific. What do you guys know from grade 7 that you can tell me about whole numbers? What is a whole numbers? Lungile Donsi, numbers like 1, yes. 1 is an example of a whole number. But what is the definition? If we were to define what whole numbers are, what would we say? Okay. And I like what has been said above. Whole number is a number that is complete, yes. But I want us to be a bit more specific. Can anyone share more specifically what is a whole number? Okay, a number without decimals. Okay, all right. Anyone else? Anything else? A whole number, Olerato says, a whole number is a number that starts from 0 and it doesn't have decimals. Nice. I love that. I love it. I love it. I love it a lot. Okay. All right. So let's formalize this definition. I like what Olerato has said, and I'm just going to use aspects of what has been said already. So yes, a whole number is a number. It starts from 0. Okay, so let's formalize it a bit more, this definition of whole numbers. So here's what we can basically then say about whole numbers. I'm just going to write down this definition. Let me just remove this poster here. Sorry. Let's remove this. Otherwise, thank you so much. Your guys' responses are on top of the game. I love it. Okay, a whole number. So whole numbers are definitely numbers so they definitely have a beginning that start from 0. So that's true. Whole numbers are numbers that start from 0 and increase by 1. Okay, so they increase by 1 up until infinity, right? And this word infinity simply means have no end. In other words, there is no end to whole numbers. There is no, like, we cannot say there is the biggest whole number. A whole number simply does have a small number, which is the smallest number that we can have in our family of whole numbers is 0. Okay, but what do we notice is the behavior of our whole numbers. They actually increase by 1. So in other words, if we're looking at our numbers, okay, if we're to look at the family of whole numbers, okay, we would start at 0, of course. That's where we begin. There's nothing before 0 because whole numbers start from 0. Then if we are increasing by 1, the next number would be 1. Then the next number would be 2. The next number would be 3. The next number would be 4. And basically that pattern would continue, all right, in an infinite fashion. So we write these dots to indicate that there are more numbers that behave in the same fashion, meaning after 4, if we increase by 1, we have 5, 6, 7, and so it goes. But whole numbers are numbers that start from 0 and increase by 1 up until infinity. And this word infinity, it's not like infinity is a number at the end. No, infinity is just an indication that numbers have no end. In other words, numbers will continue with that same behavior continuously, like without actually arriving at a certain destination. The topic, whole numbers. The grade 8. So we are doing grade 8 whole numbers, okay, for those who have just joined in. And yes, it's pure maths, grade 8. So whole numbers are numbers that start from 0 and increase by 1 up until infinity, meaning they have no what? They have no end. Okay, if we look at an example at the family of whole numbers, if we were to look at a set of whole numbers, we're starting at 0, we're going up by 1, which means 0, 1, 2, 3, 4. And so the behavior is one that increases by 1 all the way to infinity. That is the definition of whole numbers. And there is this special symbol that we use to denote whole numbers. Okay, it's this funny looking N, and then just as a subscript, we write a 0 because this is the symbol we use for whole numbers. Right? So if we don't see the word whole numbers, they could use a symbol to denote whole numbers, and that is this N with a little 0 at the bottom here. Okay, we call this a subscript. All right, if the number was as an exponent, we'd call it a superscript, but this is a subscript because it's at the bottom of the actual given letter. Okay, so this N with the 0 stands for whole numbers, and the set of whole numbers includes 0. Okay, so we use these brackets, which we refer to them as curly brackets, and then we include 0, 1, 2, 3, 4, and so it goes. All right, Call me Tsitsi. What time does grade 9 maths start? We're doing grade 9 maths in the evening at 7 p.m. All right. So we're doing grade 8 at the moment, but the grade 8 and the grade 9 will be very similar because remember the first topic for term 1 for both grades, grade 8 and 9, is whole numbers. Okay. All right. So whole numbers, I repeat again to the grade 8, whole numbers are numbers that start from 0 and increase by 1 up until infinity. Meaning infinity means they have no end. I've already done grade 10. Grade 10 I do early in the morning, 7 a.m. Grade 10 was done and dusted. But for those who missed out on that session, I will be posting that session on my YouTube channel, Maths is a Game. You guys can go onto the homepage that you see on TikTok. You can just click on the YouTube icon. It will send you to my channel, Maths is a Game. And I will basically be posting that video after I'm done with this session. I'll post that live session that I did with the grade 10s this morning on the YouTube channel. Then you can watch it there. Okay, yes, it's daily. It's daily, Olerad, daily. So grade 10s will always have a session at 7 a.m. in the morning for this week. So infinity have no end. So basically this is the symbol that we use for whole numbers, and these are the families of whole numbers. Will you be doing this lives for the whole year? Yes, definitely, Karab. I'll be doing this lives for the whole year. But I'm starting early with all grades so that they can get the benefit when they are at school of just revising the work so that it's easy for them. I hope that makes sense. So anyways, that's the beginning, okay? Then, if we look, that's whole numbers, okay? Whole numbers include another family of numbers which we refer to as natural numbers. Anyone know what natural numbers are? Okay. Now, natural numbers are numbers that start from 1. They start from 1 and increase by 1 up until infinity. All right. Okay. So I'm sure you guys are seeing the pattern here. Whole numbers start at 0. The only difference between whole numbers and natural numbers is that natural numbers don't start from 0, but they start from 1. And they also behave in the same way. They increase by 1 up until what? Infinity. Right. So the symbol that we use for natural numbers is this n, all right? Okay, and if you write the curly nice brackets, the family starts from 1, 2, 3, 4, 5, and so it goes. I mean, we could go on and on, but we know that these numbers behave in the same fashion. We just increase by 1 all the way to infinity. And remember, what did I say? The word infinity is simply a concept in mathematics that basically says numbers have no end. There is no biggest natural number because these natural numbers, they go on infinitely. They behave in such a way that they infinitely go on. Right? So that is natural numbers. Natural numbers are numbers that start from 1 and increase by 1 up until infinity. Okay? So that is our natural numbers. This is the symbol we use. If you can see, the symbol does not have a subscript, unlike the whole number symbol. The whole number symbol has the subscript 0 to indicate the beginning, because whole numbers, we learned, begin or start from 0. But natural numbers, they start from 1. They behave in the same way in that they both increase by 1, just like natural numbers also increase by 1, up until where? Up until infinity. What does this infinity mean? It simply means that these numbers go on infinitely and have no end. Okay? If you're a Buzz Lightyear fan, if you've watched Toy Story, you will know that Buzz Lightyear has that statement that he says, to infinity and beyond. infinity is ongoing, right? Okay, guys, I hope that introduction is very clear for all of us. Whole numbers are numbers that start from 0 and increase by 1 up until infinity. Meaning, what does the word infinity mean? There's no end. Then that's the symbol of whole numbers that we use, all right? And then 0, 1, 2, 3, 4. Yes, this is the first session for grade 8, Ronewa. It's the first session. Natural numbers are numbers that start from 1 and increase by 1 up until what? Infinity. And this is basically the family of natural numbers. N is the symbol that we use, and then basically this would be the family. We're starting at 1, 2, 3, 4, 5. There's no decimals, all right, as you see, which is very, very important, which is something that someone else had mentioned earlier on, okay? So it's very, very important. Of course, we'll move on and we'll explain more, and I hope that's clear. So that's basically the beginning of the session for grade 8. Now, let's look at something else. Grade 9 is at 7 p.m. tonight. Ordering and comparing whole numbers. Let's look at that. Now, when writing whole numbers, we need to pay attention to what? To the place value of each digit in the number, right? So I'm sure you guys know about placeholders. You did that in grade 7, okay? The place value of each digit, very, very important. We need to know the place value of each digit. Why is that important? It's especially important for calculations, all right? Yes, it is December, but you'll understand why we are doing this if you were actually following the live creator and you had listened to some of my earlier sessions. Anyway, it's no problem. Okay, maybe you can become converted as you are in the session. So especially important for calculations, this placeholder stuff. Then, placing digits incorrectly, meaning not placing the values in the right place value or the placeholder. Placing digits incorrectly can lead to errors in the calculations, right? That's very important. My AV for grade 12, I have not established a time yet, but I do promise a session for the grade 12s come tomorrow, Tuesday. So for now, today I'll exclusively be focusing on grade 8, 9, 10, and 11. But for grade 12s, when I post the schedule again today, which is later on this evening, I will basically post the inclusion of the time for grade 12s. So grade 12s, I don't have a session for them yet, but it's coming up, okay? Tomorrow, definitely. Okay, so this is very important, okay? The place value of each digit in the number, all right? Okay. Then let's look at the next thing. We need to be able to distinguish between what we refer to as a prime number and a composite number. Yes, for grade 12, definitely. Prime number and composite number. I want to distinguish between a prime number and a composite number. Do we know what a prime number is, people? What is a prime number? Did we do prime numbers, or did we define what a prime number is in grade 7? To my grades 8s that are here. Grade 10 I did earlier on this morning at 7 a.m. We'll definitely be having grade 10 sessions at 7 a.m. Yes, I know it's early, but that's how it's going to be. Daily sessions for grade 10, 7 a.m. And I'll definitely be posting the video of the live session on the Maths is a Game YouTube channel. I know how, very boring. But anyways, okay. So what is a prime number? I like the responses. Prime number is a number that's equal, no. Numbers that only have one and itself. Olorado, you are on the right track, but I just need something from razor blade, a number that can be divided by 1 and itself. Very good. Very, very good, razor blade. That's spot on. Spot on. Okay. It's a number that has only has 2 factors, 1 in itself, spot on. So Olerato and Razor Blade have it down. That is the definition. Okay, so both of those definitions, Olerato and Razor Blade's definition, are spot on. Okay, so a prime number is a number that has 2 factors, 1 and itself. Okay, a number that has 2 factors, 1 and itself. Okay, so I like furthermore what Razor Blade said, a number that can be divided by 1 and itself only. Okay, that's just another way of putting it. A number that can be divided by 1 and itself. Remember, guys, that a factor is a number that can go into another number perfectly without leaving a remainder. That is what a factor is. A number that fits in another number perfectly without leaving a remainder. That's what a factor is. So think about it. A prime number is a number that has only 2 of those numbers, 2 of them that fit into this particular number without leaving a remainder. And one of those numbers is 1. The other number is actually itself that particular number. So let's think of a few numbers that are like that. Examples of prime numbers that we can think of. Let me see in the comment section. I'm gonna wait for people. Example of 3. Definitely 3 is a prime number. Razor Blade, you said 2, 3, 5. Yes. Okay, so people, let's hold it right there. Okay, definitely. So 2 is a prime number, 3 is a prime number, 5 is a prime number. These are prime numbers. So basically what we do is that if we think about it, what are the factors of 2? Numbers that fit into 2 without leaving a remainder. 1 and 2. 1 goes into 2 twice. 2 goes into 2 once. There's no other numbers that go into 2 that fit into 2. So that's why we call these factors of 2. Okay, what is a prime number? It's a number that has 2 factors, 1 and itself. Look at these factors of 2. 1 and 2. 2, which is itself. Does that make sense? So that's why we say 2 is a prime number. What about 3? Let's look at the factors of 3. 1 goes into 3 as well as 3 goes into 3. Is there another number that goes into 3? No, there isn't. So that's why we call 3 a prime number. Why? Because it is a number that has 2 factors. 1 and itself, which is 3. 5. What are the factors of 5? 1 and 5. Okay, Kevin, very good. So basically, the factors of 5 are 1 and 5. 1 goes into 5 times. 5 goes into 5 once. So these here are the factors. All right, and that's why we say 2, 3, and 5 are prime numbers, because by definition, what is a prime number? It's a number that has 2 factors, 1 and itself. The factors of 2, 1 and itself. The factors of 3, 1 and itself. The factors of 5, 1 and itself. Let's say someone was to say the factors of 9 is also a prime number. Let's just say, for argument's sake, someone was to say 9 is a prime number. Now we would have to check, what are the numbers that fit into 9? 1 definitely does fit into 9. 9 also fits into 9. But is there another number? Kevin said 3 also fits into 9. So how many factors do we have of 9? We have 1, 2, 3. Is 9 a prime number? Let's look at the definition of a prime number. A prime number is a number that has two factors, 1 and itself. Are the factors of 9 1 and 9 only? No. 3 is also included. So how many factors do we have in total? There are 3 factors of 9. So therefore, can we say 9 is a prime factor? No. 9 is not a prime number. So whenever you are basically asked if a particular number is a prime number, you need to check if it fits the definition of what a prime number is. Okay. So I will repeat. Prime number is a number that has two factors, 1 and itself. In other words, it's a number that can be divided by 1 because 1 fits into that number perfectly, and itself because the number itself fits into itself perfectly as well and leaves no remainder. Okay? Right? And I'm sure you guys can basically list the other prime numbers that are between 1 and 10. 7 is also a prime number. Okay? 8 is not, 9 is not, 10 is not. So the prime numbers that are between 1 and 10, you have 2, 3, 5, and 7. So for yourself, in your own time, right, and this is what I'm going to basically be checking for homework when I basically have the live session tomorrow, please write down for homework the prime numbers, all of them, prime numbers between 1 and 100. These are numbers that you need to know. Okay. No, 3 multiplied by 2 is not 9, Olerato, please. 3 multiplied by 2 is 6. 3 multiplied by 2 is 6. 3 multiplied by 2 is 6. Do not mistake 3 times 2 with 3 to the power 2. 3 times 2 is 6. 3 to the power 2 means 3 times 3, which is 9. Okay, don't mistake the 2, Olerato, right? And this is a common thing that people make a mistake of. 3 times 2 is 6, but 3 to the power 2, it means 3 times 3, because 3 twice multiplied, that's 9. Olerato, it's fine. It's okay, right? It's okay. Okay, so I will basically have you guys for homework, please, when you have time. Okay, but actually, this is something that I'm going to check when I reconvene the live tomorrow. I'm going to ask you guys to let me know what the prime numbers are between 1 and 100. Okay? Yeah. No, I'm not going to be sending your homework. You should be writing it down, this thing here that I'm telling you now. I need you guys to write down all the prime numbers between 1 and 100. Okay? We've already identified the prime numbers that are between 1 and 10. It's 2, 3, 5, and 7. Now, all I want you guys to do is actually identify the prime numbers between 1 and 100. All of them. Okay? Please make it a point that you are able to do that. Okay? All right. How? It's December. Go swim. Tamia. You are funny. You are so funny. Okay, then let's look at another definition of numbers. Okay, I'm going to be done very soon, guys, all right? Like I said, these are not going to be long sessions, but if we nibble and we eat a little today, a little tomorrow, a little, it's all going to add up and it's going to all benefit you greatly. But I need you guys to really grasp these basic fundamentals, because if you do, it will make life very easy. Are numbers that have 2 or more factors, in other words, opposite of prime numbers? Yes, Olerato. This is what we are going to look at now. So we're going to look at another family of numbers that we refer to as composite numbers. Okay, composite numbers. We looked at prime numbers. Now we're going to look at composite numbers. What are composite numbers? Okay, and Olerato, this is where you basically should come in. And anyone else, what do you guys understand are composite numbers? Okay. Olorado already. A number that can be divisible by more than one number. Okay, please take note, razor blade. A number that can be divisible by more than, it can't be more than one. It has to be more than, it can't be more than one. Remember, 2 is more than 1, and a prime number fits the description of more than 1. So it can't be more than 1. It has to be more than, yes, more than 2. All right. So I'm going to use both razor blade and Olorado's description here. Numbers. So composite numbers are numbers that have more than, it's not 2 or more, it's more than 2 factors. Okay, I hope that's clear. Okay, it can't be 2 or more. Remember, if you say 2 or more, it's like you are including prime numbers, because prime numbers have 2 factors, right? But composite numbers are numbers that have more than 2 factors. More than 2 factors. So the opposite of prime is composite. Okay, more than 2 factors. Composite numbers are numbers that have more than 2 factors. Positive integer greater than 1. In other words, it has more than 2 distinct factors. Positive integer greater than 1. Okay, yes. Okay, I love BOB's description there. Okay, definitely it's going to be a positive integer. So composite numbers are numbers that have more than 2 factors. So for now, we are not using the word integer because we are still dealing with whole numbers. All right. When we get to the definite integers, then we will extend our definition. But for now, composite numbers, loosely put, are numbers that have more than 2 factors. All right. So 9, which was a number that we had identified earlier on, we concluded that 9 is not a prime number. Remember that? Okay, when we looked at the factors of 9, we found that 1 is a factor. We found that 3 is a factor. We found that 9 is also a factor. So the factors here are 1, 2, 3. 3 numbers that fit in perfectly into 9. 1, 3, and 9. So basically, how many factors does 9 have? It has 3 factors. So is it a prime number? Definitely not. Okay, it is a composite number. Why? Because composite numbers are numbers that have more than 2 factors. Okay, yeah. Or as very well put by, I think it was, let's see, razor blade. All right, a number that can be divisible, and I love this word, a number that can be divisible by more than 2 numbers. Okay, so it has more than 2 factors. In other words, just like 9, it has more than 2 factors. 1 is a factor of 9, 3 is a factor of 9, and 9 is a factor of 9. So 9 has 3 factors, and therefore we can refer to it as a composite number. Okay. Olerado, what does divisible mean? Divisible is just another word that means that number can fit into, can be, there's 2 more numbers that can fit into that number. All right, a number that can be divisible. So in other words, 1 is divisible. Okay, 3 is divisible to 9. 9 is divisible to 9. In other words, 9 divided by 1 gives you 9. 9 divided by 3 gives you 3. 9 divided by 9 gives you 1. So in other words, these numbers 1, 3, and 9 are divisible, okay, to this number 9. Okay, so it's just another way of saying a factor. 1, 3, and 9 are factors of 9. 1, 3, and 9 are divisible, meaning they fit into 1 1 fits into 9, leaving no remainder. 3 fits into 9, leaving no remainder. 9 fits into 9, leaving no remainder. Okay, that's what the word divisible means. Just another way of saying factor. Okay. All right, let's move right along. So I love how people here, it seems like I like how people, so Bob says or helps us out there in that definition. Bob, divisible means that one number can be divided by another number without leaving a remainder. Thank you so much, Bob. Thank you so much. You are a great help there with those definitions. 9 is a composite number indeed. So hopefully we can distinguish between what a composite number is and what a prime number is. All right. Now let's move on. Okay. So if we were to identify some more composite numbers between 1 and 10, okay, the number 1 is not a composite number. The number 1 is not even a prime number. So the number 1 is not prime, it is not composite. 2, on the other hand, we found that it's a prime number. 3 was also a prime number. Okay, so 2, 3, 5, 7 are prime numbers. But look at the composite numbers that we have here. 4, between 1 and 10. 4 is a prime number, as Olerato pointed out. 6 is a composite number. 8 is a composite number. 9 is a composite number. Yes, I will be Razorblade. 10 is a composite number. So these are all numbers that have more than 2 factors. Okay, which is very important to note. Ooh, okay, I'm getting a restriction here. Okay, guys, restriction. Okay, yeah, guys, TikTok has restricted me in the past because the minute I start mentioning numbers, they think I'm gambling, and that's not the case. So I don't know if that does happen. I will have to gravitate towards my lives on YouTube because, yeah, I don't know why, but it just happens. Okay, let's look at this now. We've looked at prime and composite numbers, and hopefully we are clear about them. Let's look at even and odd numbers. Now, if a whole number is divisible by 2, then it's even. I repeat, if a whole number is divisible by 2, then it's even. All right, so this is the definition of even numbers. If a whole number is divisible by 2, then it's even. Okay, so even numbers, when we look at even numbers, does anyone know what the smallest even number is? This I want to see. Smallest even number. Kyla, Jay-Z, yes, those are composite numbers. 4, 9, 15, and 21 definitely are. Do we know what the smallest even number is? So Razorblade says 2, Olerato says 0, and I just want to shockingly reveal that the smallest even number is 0, guys. Okay, let me just... Okay, guys, just hang tight. I need to attend to something very quickly. I'll be back in 5 minutes. So for now, maybe you guys can let me know what the definition of an even number is, as I had explained it, and then let me know what is an odd number. If an even number is divisible by 2, then what about a odd number? What is the definition of a odd number? Even number, okay? If a whole number is divisible by 2, then we say it's even. I repeat, a whole number divisible by 2, then it's even. Okay. All right, so hopefully that's very clear for you. Now I'm gonna leave you just shortly because I need to just attend to something. I'll be back in 3 minutes. Just hang tight. You guys can just let me know what an odd number is. If the definition for an even number is when a whole number is divisible by 2, then we call it even. What about an odd number? What is the definition of an odd number? So I'm just gonna Yes. Okay, I like it. Odd numbers are numbers that can't be divisible by 2. Very true. Okay, thank you so much for that definition. Hopefully, we have all registered that definition because, yeah, if even numbers are divisible by 2, then we know that odd numbers are numbers that are not divisible by 2. Okay, and obviously with the examples, We're looking at odd numbers. We have 0, 2, 4, 6, 8, 10, and so it goes. With odd numbers, we have 1, 3, 5, 7, 9, 11, and you guys understand and you can see how the fashion of numbers goes. I mean, if you were in grade 7, you come into grade 8, you should be able to know the difference between even and odd numbers, even by that definition, okay? Yeah, so it applies to obviously 4, 6, because 4 is divisible by 2, 6 is also divisible by 2, 8 is divisible by 2, 10 is divisible by 2, and so it goes. But you can see that 1, 3, 5, all these other numbers are not divisible by 2. Hence we say these are odd and these ones are even. These are even, and these ones are odd. Sorry, that mistake there. Not good. Okay. All right. And guys, we are literally coming to the end of the very first session, because the first session was simply us being able to recap and look at what we've already done in previous grades, looking at the difference between whole numbers and natural numbers. That's the first thing. Secondly, looking at the difference between prime and composite numbers, and then looking at the difference between odd and even numbers. So once we have that difference clear, all right, then we can look at other aspects, okay? But it's very important to first and foremost know the difference between whole numbers. Remember, we said whole numbers are numbers that start from 0, they increase by 1 up until infinity, meaning they have no end, okay? And then we looked at the symbol, we looked at the family of numbers starting from 0, but there is no end, so they go on forever. We looked at natural numbers. We said those are numbers that start from 1, okay, and increase by 1 up until infinity. Then we looked at the family of those natural numbers. We looked at the symbol, we looked at the family. Then we looked at the definition of prime numbers. We said that prime numbers are numbers that have what? 2 factors, 1 and itself. In other words, we said those are numbers that can be divided by 1 and itself. Okay, and we looked at these numbers 2, 3, 5, 7. Okay, and we saw really and truly that 2 does only have 2 factors. 3 does only have 2 factors. 5 does only have 2 factors. Then if we looked at a number that's like 9, 9 is not a prime number. It is a composite number. And we looked at the definition of composite numbers. That composite numbers are numbers that have more than 2 what? Factors. Okay? Numbers that can be divisible by more than 2 numbers. Very important. Okay? Yeah. And then after that, we looked at the difference between even numbers, okay, and we said that even numbers, if a whole number is divisible by 2, then we say it's even, okay, and we looked at the example. The smallest even number is 0, 0, 2, 4, 6, 8, 10, and then we looked at odd numbers. We said that odd numbers, they are not divisible by 2, and then we looked at 1, 3, 5, 7, 9, 11. So these are very important basics we need to have down. The last thing I want to look at is what we refer to as consecutive numbers. This word is a very important word that you need to be very much familiar with in grade 8, 9, 10, 11 for your pure maths. So the word consecutive, this word, it's grade 8 that we are doing, guys. Those who are joining in, it's grade 8. Grade 10 was done at 7 a.m. We are now busy with grade 8 at the moment, all right? And if you want to find out when the other grades are being done, not grade 12 though, but grade 9 and 11, please go on to my homepage. The schedule is there. That's when I'll be doing the times I'll be doing those other 2 grades, okay? Now, the word consecutive means next to each other. In other words, following each other without missing anything. I repeat, the word consecutive, because consecutive numbers, consecutive means next to each other, following each other without missing anything. So that's why, for instance, if I'm looking at this family of even numbers, these are consecutive. 0, we are going up by 2. 4, going up by 2. 6, going up by 2. 8, going up by 2. 10, going up by 2. Consecutive, following each other, not missing anything. Look at these odd numbers. These are also consecutive. This is grade 8. 1, 3, 5, 7, 9, 11. These are consecutive odd numbers. These are consecutive even numbers. Does that make sense? So this word consecutive means next to each other, but this next to each other means following each other without missing anything. All right. So that's why they say we have what we call consecutive odd numbers. Obviously, consecutive odd numbers, where will they start? If we're talking about consecutive odd numbers, they'll start at 1. And we count up in 2s, right? Because from 1, we move on to what? To 3. We are counting up in 2s, meaning we count up in 2s without missing anything. So that's why we call these consecutive odd numbers. We'll start at 1 and count up in 2s. Look at this one. Consecutive even numbers. This is grade 8, guys. Grade 8. But it's also applicable to grade 9 because of the similarity in syllabus. Consecutive even numbers. What about consecutive even numbers? These must start with an even number, like 0, and go up in 2s without skipping any numbers or without missing anything. All right? So this is just in summary, guys, what we have. Why is it so easy? Because it is easy. Batman, it is easy. All right? But this is how your grade 8 syllabus starts. We start off by recapping on what you've already done in grade 7. And we look at the difference between whole numbers and natural numbers. We look at prime numbers and composite numbers. We look at odd numbers and even numbers, and then we look at basically what consecutive numbers are. All right? And very importantly, guys, is being able to distinguish the difference between these numbers and be able to answer questions that I can ask of any latitude or any magnitude where this grade 8 content is concerned. So I'm going to turn my attention very quickly to just a few basic questions around what I have just taught you and see if people can actually answer these questions, just as a sort of like exercise to check if we have understood what we have learned. So just hang on tight for me. I just want to go to a place where I can actually identify some questions that you guys can answer, and then we'll see in the comment section what you guys have to say. This is grade 8, okay? Just hang on. Just need to get the questions. You guys kind of make me laugh about why you guys are saying, why is this so easy? What are you guys expecting? It's like some of you have traumas from what you think will be happening in this grade 8. Yeah. Anyone who's serious with this grade 8 syllabus we should be able to kill it and just do very well. Do it again, please. Do what again, please, to me? I will not be doing this again, all right? I will basically upload this session on my YouTube channel. You can watch it. Maths is a game, okay? Unfortunately, guys, I will not be able to do this. I am in a time sort of like, squeeze. There are things I need to be doing shortly, so sorry, guys. You can, like I said, what you can do is you can make sure that you go onto my YouTube page, Maths is a Game. I'll be uploading the video of what I've just covered with you guys, and then, yeah, you can check it out there, all right? So I'm very sorry, very, very sorry. Hopefully you guys can find it in your hearts of hearts to forgive me. And then, yes, tomorrow there'll definitely be another live, guys. Definitely another live. Doing daily lives for the respective grades. But just take note of when I do them, okay? Take note of when I do them. I will upload the schedule for tomorrow on the page. Okay. I will upload the schedule on the page. So patience is a virtue. It's the mother of all. Okay, so let's just check. I know, some of us are sleeping. Yes, it is extra maths, Demisibia. It is like extra maths, okay, for all grades. Okay, I post up the schedule on my page, and then people can join in on the allocated time. All right. And this is to try and help people to get prepared already in the festive season for the next grade, and by so doing so.